First thing that I want to talk about, and it is just introducing what are the inverse trig ratios. Okay, and we're going to look at three of them. And the way that you're going to see them written is like this. This is sine that what looks like the power of -1. This is called the inverse of sine. And it could also be called arc sine. And so those are two different ways to say the same thing, but this is the inverse. And if you remember, an inverse happens in two different ways. When you exchange the x and y and solve for the new y. Okay? Or if you take your graph and you reflect that graph along the equation y, the line y equals x, that sort of imaginary line across y equals x. Okay, now, because these functions here, the sine, cosine, and tangent functions are cyclical, okay, they are waves that continue. If you fold it along the y equals x graph, it's not going to be a function. Okay, and so the inverse for trig ratios, it has to be limited, kind of like, again, we didn't spend a ton of time talking about it, but when we did parabolas, remember how in order for the function to have an inverse, it has to pass that horizontal line, the one-to-one function. And so what we would do is we would only take half of the x squared graph, and then when you reflected that, it became a square root looking graph, okay, because you needed it to be a function when you take the inverse. Well, that whole process here is going to work with the sine, cosine, and tangent. Okay, and so what we need to do when we're looking at these three inverse functions here is we have to limit the portion of the graph to represent this. Okay, and so here's kind of where that winds up being limited. And again, we're not going to spend a ton of time. We're not going to graph these. Next year, you guys will graph these. Okay, but if you were to take a sine function that looks like this, right? What we have to do is we have to limit it to a portion of this graph that passes the horizontal line test. Okay, and so the way that we're going to limit that is, so can we limit it to this? Can we limit it from 0 to 2 pi? Does that pass the horizontal line test? No. So what we have to do is we have to limit it from this point to this point. And let's think about what that is from the unit circle. Bless you. So this is pi over 2. This is negative pi over 2. And so what we see for this, the inverse of sine, is you have to limit it between negative pi over 2 and pi over 2. If you take the inverse sine on your calculator, okay, it's only going to give you an angle between negative pi over 2 and pi over 2. Now, that doesn't mean that you can't find other angles that have the same sine ratios, but if you're using the calculator to find the inverse, or to find an angle whose sine is some value, which is what the inverse stands for, okay, then you have to limit it. Okay, so let's take a look at this problem, and we'll kind of explain what this all means through the example here. Okay, so when I look at this expression right here, this is asking me what is the inverse sine of negative pi over 2. Okay, what that means is what angle has a sine of negative pi over 2. Well, in the unit circle, negative pi over 2 for the sine is in which two possible quadrants? 3 and 4, right? These have the negative sign. Remember, sine corresponds to the y coordinate. So we're looking at this angle right here or this angle right here. Okay, well, when you're looking at this interval from negative pi over 2, which is right down here, all the way to pi over 2. So this is the corresponding interval on the unit circle that corresponds to this interval on the coordinate plane. Okay, so which of these angles is going to be the, again, what we see, negative root 2 over 2? What is this angle right here? It's in the negative direction, and it's what radian measure? 45 degrees, right, in the negative direction, which in fraction form is 1/4 pi, right? It's 1/4 of pi, the rotation of pi in the negative direction. So negative pi over 4 is going to be the angle whose inverse sine is negative root 2 over 2. All right, let's take a look at cosine. So the cosine function by itself starts up here, okay, and it looks like this. Okay, so there's your cosine graph. If we want to limit this to a portion that passes the horizontal line test so that its inverse will also be a function, can we take the same thing for negative pi over 2 to pi over 2? Does that pass the horizontal line test? No. So what we can do, though, is if we start from 0, we can go all the way to this value right here. So the cosine function passes the horizontal line test so that its inverse is also a function from 0 all the way to, and you can kind of see it here, pi. Okay, so that's the value on this unit circle here where you can find where your cosines don't overlap each other. Okay, so there's a different cosine everywhere between 0 and pi radians. There's no two angles that are going to have the same cosine in that interval. Okay, and so that means when we look at this question right here with the inverse cosine of 1/2, okay, which possible angles will have an inverse cosine of 1/2? Well, 1/2 is right about here, right, for cosine, the x-coordinate. So we're looking at this angle and this angle. The one that falls in this interval from 0 to pi is up here, and what was that angle measure? Where the shorter leg is the 1/2, the root 3 over 2 is the vertical part, so we have 1/2 root 3 over 2 is that is the point on the unit circle, and what is the angle measure right here? It's 60 degrees, and in terms of radians, that is pi over 3. Right? It's 2 pi over 6, right? Pi over 6, 2 pi over 6 gets you there. Okay, and so that would be your answer for the inverse cosine of 1/2. Okay, the final trig ratio that we're looking at is tangent. Okay, and so when we haven't done the tangent graph, so I'm just going to sketch this for you. Okay, so the tangent graph looks like this. Again, it does cycle through, but this is your tangent graph from here to here. And then it just repeats that same pattern continuously. And so when you look to see what portion here passes the horizontal line test, and you see that it's all those values between. And so when you are looking at this, it's negative pi over 2 to pi over 2 as well. Okay, so the same interval that gives you the inverse sine will also give you the inverse tangent. And so down here, when we look, what is the angle between negative pi over 2, which is down here, to pi over 2, right here? Again, we're looking at this whole interval from here to here. Okay, which angle in that interval right there will have a tangent of 0? Remember, tangent is sine over cosine. So to have a tangent of 0, which of the trig ratios has to be 0, the sine or the cosine? Sine has to be 0, and sine corresponds to the vertical, the y-coordinate. So what angle has a sine of 0 between negative pi over 2 and pi over 2? Just 0. Okay, and so that would be your answer for that. All right, we will be coming back to this, and we'll show you here in one of the later slides how you can use that information to find an angle that's in any of the quadrants, okay, not just the one that's designated for the individual inverse. But that is something that you need to restrict. Okay, now, looking at all of these problems, the restrictions are given for you, right? They're given here. But you are going to, for next year, you're going to need to know what those restrictions are and where they are. Okay. All right. So this, like what we did over here, is how you can answer these by hand. You should be able to use the unit circle and answer in the properties of inverses and which intervals contain the inverse to evaluate those by hand. And you also need to be able to evaluate them by using a calculator. Okay, and so let me pull up a calculator here. All right, so the inverse sine, or the inverse trig ratios, you might need to use this second button here. But when you look here, if you hit the second or shift, that up arrow, you can turn these into their inverse trig ratios. You might also see the word arc sine, arc cosine, arc tangent. And those might also appear. And when you do your calculations, just normal, you don't have to do anything different. The angles that they give you will fall in the intervals of that inverse. Okay, so if I'm calculating, let's say, this first, or let's say right here, if I'm evaluating in degrees right here, which angle has a tangent of 0.6512? And what angle has that? Well, the way that you can find what angle has that is you just type this into your calculator, make sure you're in degree mode, which I am, right? I can toggle back and forth, degree and radian, but I want to be in degree mode based on this interval. And if I calculate 0.6512, and then I hit second tangent, I can evaluate the inverse tan of that, and I get 33.07 degrees. Okay, and so that's the angle that has a tangent of this 0.6512. Okay, I want you to try calculating these remaining two on your own. Okay, can you find what angle has that given cosine, which angle has that given sine, based on your calculations? And again, you will notice that in those highlighted intervals, like those are the intervals for which the inverse is defined. Okay, so your calculator is going to give you values that fall in that range. And so this next answer should be some number between 0 and 180. If I take my ratio, 0.8295, and I take the inverse cosine of that, so second cosine gives me the inverse cosine, I get my angle to be 33.95. And that is the correct answer. And then finally, my last, what angle has a sine that's this negative 0.7603? Change the sign negative. So here, when I take my inverse sine, I should get an angle that falls somewhere between negative 90 degrees and positive 90 degrees. I get negative 49.49. And so those are the angles in terms of degrees. Okay, I want you to try the same thing, but in terms of radians, using or answering these three questions here. So do make sure you change your calculator to radian mode. All right, so basically when you are working through these problems, the setup, and you're going to see the setup when we do the applied problems here, but when you have this expression right here, it allows you to find what angle you find the sine of what angle is equal to that measure. Okay, so if you take this as your known piece of information, you can calculate it by saying that the angle is equal to the inverse sine of that ratio. Here, the ratio that they gave us for this. Okay, so when we do our calculation for this, we take our 0.8086, change the sign to negative. What angle has that as its sine? So we take the inverse sine. And this is our answer in radians. Okay, and it is a value between negative pi over 2 and pi over 2, if you looked at the decimal value for that. But you get negative 0.9418. Okay, the inverse cosine of 0.8293. Take the second cosine, the inverse cosine here, you get 0.5929. And then finally, the inverse tan, we take that 0.3722, change the sign. And we take the inverse tangent of this. And this gives us the angle for for which the tangent ratio is that given measure. And so that angle is going to be negative 0.3563. All right, now the problem that generally comes with working in radians is if I tell you 33 degrees or even negative 49 degrees, you guys have an idea of where that is, right? It's about negative 50 degrees in quadrant 4. Okay, but the radians, you don't really have a great idea of what those represent. Just do keep in mind, you do know pi is 3.14, right? So 1.57 would be half of that. So if I'm going in the negative direction or positive direction here, so it would make sense that negative 0.3563 is going to fall in quadrant 4, right? It would make sense that negative 0.9418 is going to fall in quadrant 4. So it gives you an idea just by using those partial decimal forms for what you do know. All right. So let's see how this is going to be used in the more complicated way. All right, what if it asks you to find the angle whose sine is some ratio, just like what we just found in the calculator, but instead of it being in quadrants 1 and 4, which is where the sine, the inverse sine on your calculator is going to give you, what if it asks you find it in quadrant 3? What angle in quadrant 3 is going to have that sine? So again, if you're thinking about the visual part of this, remember a negative sign can exist here and here, right, in quadrant 3 or quadrant 4. So it's asking you what is this angle right here, okay, such that you have this sign, the y value is the given measure, negative 0.4072. Right? Now, if we calculate this on the calculator, so if we take the inverse sine, so we want to be in radian mode, right? From 0 to 2 pi, that gives us the information we want to be in radian mode. And so if we take this ratio right here, 0.4072, change the sign, and we take the inverse sine of that. So this right here is what our calculator tells us, negative 0.4193. Okay, that's this angle right here. We know that measure. Okay, but we're being asked to find an angle from 0 to 2 pi. So now it's asking us to go in the counterclockwise rotation of the positive rotation of the angle. And we want to find this whole angle here to here. What is this whole angle? Okay, well, what you're going to do to find this is you're going to use reference angles. Okay, because here when we calculate this, if this angle is 0.4193 in the negative direction, that means that when I find this whole measure from here to here, I'm going to take pi, right? That takes me all the way to this point. And then I need to rotate how much more? I need to rotate this reference angle more. So I'm going to take this number that I have right here. I'm going to change the sign. And then I'm going to add pi to that. And that gives me my total angle of 3.56. It wants to 4 decimal places. So 1, 0. Okay, and so this is the way that I calculated that, right? So I took this whole measure of pi, and I added my reference angle, which I'm going to mark as an absolute value of negative 0.4193. And that's going to give me the total angle measure in quadrant 3. Now, what I can do to verify this is if I take this measure right here that I have in my calculator right now, and I calculate the sine of this, what should the sine of this equal? What number? When I take the sine of this angle, if I know that this is asking, or I'm trying to find what angle in quadrant 3 has a sine of this. So as soon as I hit the sine of this button, I'm expecting it to say negative 0.4072. And it does, right? So I can confirm that I have the right answer. okay, before I hit check solution on a quiz or a test. Okay, I want you to try the next one for cosine. Do the same thing and try that for the cosine. When I use the calculator to calculate what angle in radians has this given cosine ratio. So if I type in 0.6095 and I take the inverse cosine. So I get 0.915. Well, 0.915 is going to be somewhere along here, right? 0.9154. Right? So it wants me to find in quadrant 4. So I'm looking at this quadrant down here that has that same cosine. The cosine is the x-coordinate. So if I imagine this x line going straight down, so here is the angle I'm finding, right? This full rotation here between 0 and 2 pi. And so the way I can find that is, and again, I'm not writing a formula for it. I'm looking at it visually. To find this angle from here to here, I don't take pi and then add some value, right? What I'm doing is I'm going to take this whole rotation from here to here, and then I'm going to remove this reference angle because this 0.9154 is also the same reference angle here, 0.9154 in the negative direction. So what I can do with my calculator here is I can change the sign of it because I'm going to take 2 pi and I'm going to subtract 0.9154, right? So if I take all of this and I add that to 2 pi, so 2 times pi, close that off and hit equals, I get my answer of 5.3678. Right? And so this is my radian measure that has that same cosine value. Okay? It's not what the calculator is going to show me because the calculator only wants to show me quadrant 1 and 2. So if I want to find it in quadrant 4, I need to use this visual process. Okay, now, can I confirm that this is true? Well, if I take the cosine of this calculated value, do I get the number I was expecting, the ratio I was expecting? Yeah, the 0.6095. All right, so try one last one. Try with the tangents here. See if you can find what angle has this tangent ratio but falls in quadrant 2. So remember that the calculators are going to give you quadrant 1 or quadrant 4 for the tangent, for sine, and then quadrant 1 and 2 for inverse cosines. Right? So I know that when I type this into my calculator, so I type in 0.1297, change the sign, and I take the inverse tangent of this, I get my angle to be negative 0.1290. Okay, so this rotation right here is 0.1290 in the negative direction. Okay, so that's what I get from my calculator. Okay, so which other quadrant here, if you look in quadrant 2, so this is the quadrant that we're looking to find this in, this reference angle of 0.1290 is going to move up this direction. Okay, so I can find this corresponding angle from here to here by taking this whole rotation of pi and then coming back this reference angle. And so here I can take pi minus this reference angle, 0.1290. Okay, so if I come back that direction, I take the absolute value of this number, which is a positive, so I'll just change the sign. And then I'm going to subtract that from pi, which winds up being, right, I change it back to a negative and add pi to that. So if I look at this angle right here, comes back up 3.0126. Okay, and so that is going to be my angle in quadrant 2 that has that same tangent ratio. And once again, if I just take the tangent of this to verify, is it the number I was expecting? Yes. And so those are that is the process for working through these. All right. Confusing? A little bit? Okay. again, this is something that's more for next year. So when you guys start going through this next year, hopefully it will kind of have made sense that you've at least connected a little bit, that the calculator is not going to show you all possible values. You might have to use sort of the visualization of what do those reference angles do, and how can you find where the other pieces go. Okay, I want you to try, turn your calculator into degree mode. Okay, I want you to see if you can find these remaining values here. Can you do this same process with inverse, sine inverse, cosine inverse, tangent? All right, so sometimes the visualization of degrees winds up being a little bit easier to see because you guys know what 50 degrees is or 80 degrees or whatever. And so if I first change my calculator to degree mode, which I've done, take my ratio, 0.4231, and when I evaluate the inverse sine of this, I get 25 degrees approximately. So that's going to be right about here, right? 25.03. All right, so when I look at that and I want to find in quadrant 2 the same y-coordinate, so the same height of this, well, I'm going to have this whole angle from here to here. I'll use a different color. Okay, so this initial side to this terminal side, that's the angle that I'm looking to find, and I can find that using this reference angle because this angle right in here is also going to be 25.03. So I can find the total angle from here to here by taking 180 and subtracting this 2503. So if I change the sign here and add this to 180, I get my angle measure. So 154.97 approximately. Oops. Is going to be my solution. And I can confirm this before I mark it, is to say if I take the sine of this, I expect my sine to be 0.4231. Oops. So if I take my sine, I do get 0.4231. So it confirms that I have the correct angle measure. Okay, so cosine, looking at this next one, I calculate using my calculator. I'm in degree mode, so 0.9553, change the sign. And I'm going to take the inverse cosine. So I get 162 approximately. So that goes all the way to here, right? This whole angle is my original angle of 162.8. And now, this is not a reference angle though, right? My reference angle is actually this angle from here to here. So I need to find what that reference angle is. So that's the difference between 162.8 and 180. Oops. Let me go back and calculate that. So 0.9553 inverse cosine. So if I take this measure right here and I find what is the difference between that and 180, it's going to give me my reference angle. So this reference angle right here is 17.2 approximately. And so if I want to find the angle that has this exact same cosine, which is an x-coordinate, I need to go 17.2 degrees past that 180, right? So if I'm going to take this measure, I'm going to add it back to 180, and that gives me the total value of my angle, 197.20 approximately. And that's this angle from here all the way down to here. Okay? And so I'm using the reference angles there to calculate, and if I want to confirm, I can take the cosine of this, and my expectation is it's going to be negative 0.9553. So when I do, it confirms that I have the right measure. Okay, and then the final one, I have the inverse tan. I take my ratio, 0.2086. The inverse tan tells me what angle has that as the tangent ratio, and it's going to be 11.7 degrees, so right here, 11.78. So there's my reference angle. And because I'm dealing with tangent in quadrant 3, I'm going to use this reference angle right here to move down. So this is going to be 11.78 as well, past the 180. So if I add this to the 180 degree rotation, I get my answer, which is 191.78 approximately. So there is the solution for that, and if I want to confirm it, I can take the tangent of this angle, and it should have the same ratio, 0.2086, and it does. All right, so this concept is a challenging concept that students face next year when you're doing pre-calc. And so just, I wanted to introduce it a little bit. I know we spent a long time going through the different variations of this, but I just want you to see where in my opinion, it's easier just to draw the reference triangle or the reference angles and solve this visually. All right, so the main place that you're going to see these inverse trig ratios is to find an angle if you're given other pieces of information. Okay, oops. Just notice this. All right, so if you take a given right triangle and you know at least two of the sides, what you can do is we can find this angle measure. Okay, we can find this unknown angle because with respect to this angle, we are going to use trig ratios, so SOHCAHTOA. You need to remember that. With respect to this angle, we have the opposite leg and the hypotenuse. Which trig ratio relates opposite and hypotenuse? Sine. So we know that the sine of theta is equal to 28 over 32, which is a ratio, and it is a decimal answer. And so if we want to find what is theta, then we take the inverse sine of that ratio. Okay, and so in our calculator, once again, what we can do right here is if we take 28 divided by 32, and we take the inverse sine of that. Now, we are in degrees, so make sure your calculator's set to degrees. Okay, and if we take the inverse sine of this, we get our angle to be 61.04. And that is your answer. That would be the angle for that triangle based on the given ratio. All right, I want you to see if you can set up the remaining two and use whatever trig ratio they give you, and then use the calculator, find its inverse, and identify what is the actual angle measure for each of those. All right. Notice in these other two problems, in the instructions, it specifically asks you to find radians. Okay? You do need to read these very carefully. Okay? Every time you're working with trig ratios, make sure you know, is it asking me for degree or radian mode? If it doesn't specify, you assume it's radians. Okay? If you don't see a degree symbol, consider it radian mode. Okay? So with respect to this angle, I have an adjacent leg and hypotenuse, which trig ratio relates adjacent and hypotenuse. Okay? So cosine of theta is equal to adjacent 11 over hypotenuse 39. Therefore, theta is going to equal the inverse cosine of that ratio. And so here on my calculation, I take 11 over 39, take the inverse cosine, and I get 73. Oops, what did I do wrong? I actually did it before or right after I warned you guys. Yeah, this is not in radians. This is the correct answer, right? 73.62 is the correct answer if it was in degree mode, but it's not. It's in radian mode, so let me redo that. So I take 11 divided by 39, and I'm going to take the inverse cosine, and I get 1.2849, and that would be my radian measure. Okay, the final problem here, with respect to my known angle, I have an opposite and an adjacent. Which trig ratio relates opposite and adjacent? TOA, tangent. So the tan of theta is equal to 17 over 15, which means I can calculate my angle by taking the inverse tan of that ratio. And so here again, I'm going to emphasize radian mode. I'm already in it. Okay, so let's take the ratio 17 over 15. And then I'm going to take the inverse tangent of that, and it gives me my radian measure 0.8478. Okay, and so that would be my answer. All right,